So today we are going to do Sommerfeld fine structure constant. The aim of the experiment is to determine the Sommerfeld fine structure constant alpha using a grating. The apparatus needed are sodium lamp, transmission grating and spectrometer. So regarding the apparatus, this is the telescope, this is the collimator, this is the prism table. As for the apparatus other needed, this is our transmission grating. You need a spirit lamp to balance the prism table, and that's all. The step 1 of the experiment is to adjust the telescope such that you can observe a distant object. In order to adjust the telescope, you need to focus on some distant object, let's say for example the PG building, and then you need to focus that PG building using the screw. As you can observe, next step of the apparatus is to set the collimator. First step is to make the slit as thin as possible. You need to adjust the slit using the screw such that it is as thin as possible. Next step is to observe the line spectrum. So in order to do that, you need to observe through this telescope, and you need to adjust the screw such that you will see a very thin line spectra which is crystal clear. Next step of the experiment is to rotate the telescope 90 degrees towards your right or towards your left. Any direction works. So I have moved my telescope to somewhat 90 degrees. Next step is grip your table and move the prism table 45 degrees.
Our aim today is to observe the absorption band spectra.
When you move it to 45 degrees, you will be able to observe a thin fine spectra. If you can observe the thin fine spectra, go back to your original position and bring back the table to its original position. If you cannot, then you need to redo the apparatus. So this is the adjustment you need to make for 45 degrees of the grating, and then you will be able to observe a thin spectra. You bring back the telescope to its original position and also set the prism table again perpendicular to your collimator and telescope. Now adjust the telescope in such a way that your cross wire is on the thin spectra, and take the direct reading from either this scale or this scale, and this will be your final direct reading which will be used in your calculations. Now for the next step, I'll be moving the telescope to my right as shown. You can move it to your left, that's no issue. So I have moved it to my right to observe the first order spectra. As we can observe, the first order spectra consists of yellow, green and red doublets. Now the doublets are very close, so we cannot observe the distance between them. So we will be moving the telescope to our right in order to observe the second order spectrum. Now move your telescope to your further right in order to observe the second order spectrum. As shown, I have done the adjustment. Now you can observe that the second order spectrum in the telescope, the distance between the two lines are now quite observable. You can easily record the readings of the two lines using your previously used scale and note it down. Using the formula, I have calculated the values of alpha for green, yellow and red, and we'll be taking the average of all the 6 values and calculate our final alpha value. Our final alpha value has come as 0.007, which is equal to the calculated value of alpha from Bohr's theory, that is 1 by 137 is equal to 0.0072.